Today we're going to take a look at and review all the laws of exponents. And we've worked a little bit with exponents in order of operations, but there's so many rules out there involving exponents that I definitely want to take the time to go back over them. All right, so when we think of an exponent, we definitely have a large number here, which is what we call a base, and then the little number up here is an exponent. But what do exponents help us to do? They help us multiply a lot quicker, and what this means is that we're multiplying 3 factors of 4. So exponents tell us how many factors of the base there are. So when we multiply powers with like bases, going over a very basic example, which everyone should be familiar with. So again, the bases have to be the same for this law or property to work. So what we do is we state the base once and we simply add the exponents, because what this means is I'm multiplying 2y's to get the y squared, and then 6 more y's I'm multiplying. So since everything is being multiplied together, now I have a total of 8 factors of y. So in other words, we could look at this as we have 2 factors of y times 6 more factors of y, giving us 8 factors of y. So when multiplying powers with like bases, we state the base once and add the exponents. Now, most of the time we're used to seeing problems like this where the bases are variables, but this works for any base that's the same. So even if I took, let's say, 2 to the 5th times 2 to the 4th, my base here is what? It's a 2. So in other words, I'm multiplying 5 factors of 2 times 4 more factors of 2, so I would have 9 factors of 2. We do not multiply the 2 times 2 and say it's 4 to the 9th. We state the base once because I want to know how many factors of 2 do we have, and that would be 9. Let's try this one. Let's do x to the m times x to the third. Now here we have a variable as an exponent as well, but that's okay. We simply follow the rule. When multiplying powers with like bases, we state the base once and add the exponents. Here our base is what? It's an x. And then I'm going to add the exponents, which becomes m plus 3. I just can't combine them any other way. It just stays as an m plus 3. Now we can also have coefficients in here. So let's say I have 4a to the 5th, and we can bring in multiple variables here, and then b cubed. There could be parentheses, and then say we have a negative 3ab to the 4th. Well, since everything is being multiplied, I technically don't need the parentheses, and then I could rearrange this. I could just say it's 4 times a negative 3. Now, because the 3 is negative, I am going to put that in parentheses. Then I could say a to the 5th times a. I could rearrange all my terms that are all my factors here. And then I have b cubed times b to the 4th. It's just easier when we see the variables together. So 4 times negative 3 will give me a negative 12. I'm multiplying 5 factors of a, and then really I have a to the first. So I'm going to state the base once and add the exponents, and then I'm going to get b to the 7th. So in other words, if I had to write out all of these a's and b's, I would have 6 a's multiplied together and then 7 b's multiplied together. All right, so what happens when we divide powers with like bases? Well, that's where we subtract. We state the base once and subtract the exponents. So let's say here I have m to the 9th over m to the 4th. In other words, we're really answering the question, where are there more factors and how many more? Now, when I was multiplying, I didn't have to ask where are there more factors. I had all my factors kind of, if we look at the same part of the fraction, they were all in the same place here. So all I had to do was count up how many factors I had altogether. Here for number 1, where do we have more factors of m? Up top. And then how many more? So it'd be 5. So in other words, I would have all 4 m's down here divide out with 4 m's from the top, So I'm going to keep this as a numerator, which I really don't even need to write a fraction, but I have 5 more factors of m in the numerator. What if that was reversed? What if I have m to the 4th over m to the 9th? Now where do I have more factors of m? In the denominator, so that's where I put the m. How many more? 5. Now what's going to happen is when they divide out, it becomes a 1, so we're going to have 1 over m to the 5th. And then we're going to talk about negative exponents. So I was able to avoid negative exponents here in number 2. But let's take a look at another one. Let's say I have n to the 5th and then p squared over n to the 8th and then p. So here I have a couple variables, but notice my powers of n. We would just want to ask, where do we have more n's? And that would be in the denominator. How many more? I'd have 3. Where do we have more factors of p? In the numerator. How many more? Just 1. So this simplifies to just p over n cubed. Now let's bring in some coefficients as well. So let's say we have negative 15 a to the 4th b cubed over 25. Let's do a to the 10th and b. Now the coefficients, imagine if I were to just give you the fraction negative 15/25. These are not exponents. They're not going to follow the exponent rules. So all we do is simply simplify. So 5 can go into both of these. 5 is going to go into negative 15 and negative 3 times, and then 5 is going to go into 25 5 times. So right now I've got a negative 3 over 5 because I divided top and bottom coefficients by 5. Next I ask myself, where do we have more a's? That would be the denominator. How many more? 6. Where do we have more b's? That would be the numerator. How many more? 2. So let me put one more up here. What if I had x to the 4th divided by x to the 4th? Here, where do we have more factors of x? Well, they're the same, aren't they? So I don't have any more in the top than I do in the bottom. So what's going to happen is if I were to subtract the exponents, I would get what, guys? A 0. If I put it in the numerator or denominator. But if I also look at it as 4x is being multiplied in the numerator and denominator, these all cross out, and I'm left with 1s every time they do cross out. So this gives us anything to the 0 power is 1, and this is a good example of why, because every factor divides out. We have the same number divided by itself, which is 1, which means we have no factors of x left. And that's why we're saying anything to the 0 power is 1. All right, so let's take a look at these next two. And again, there's so many different types of problems we can be dealing with here. Some of these will get a little complicated, but understanding the most basic laws and rules here is what's going to help us. So when we have a power to a power, this is saying we have some power of we'll just call it x inside, and then we have a power on the outside. So let's take a look here. Let's say if I have x cubed to the 4th. Well, we've already added the exponents. It didn't look like this. We've subtracted the exponents. Definitely didn't look like this. So what do you think we're going to do here? Multiply the exponents. So any power inside being raised to another one becomes x to the m times n. Another way to look at this, we could expand this to say x to the 3rd times x to the 3rd times x to the 3rd. Now this is where we would add the exponents, or to break it down even further to really get a good idea, I've got 3 factors of x times 3 more factors of x times 3 more factors of x. So any way you look at this will give us x to the 12th. Let's try a 4 x to the 5th squared. Now here, because we have a coefficient, I'm not multiplying the 4 times 2, I'm raising it, so this really becomes 4 squared times x to the 5th squared, which is actually what I'm going to get into in this next law here. So 4 squared will give me 16, and then I multiply the powers here, so I'm getting 16x to the 10th. And let's try one more. Let's say I have x to the 3a, and then raise that to the 2a minus 1. Now, because this exponent on the outside is a binomial, I want to put that in parentheses because now this becomes x to the 3a times 2a minus 1. And when I go to multiply, I just have to distribute. So it's going to look a little weird, but it's x to the 6a squared minus 3a. And all we're doing is we're just following the law that this problem presents. All right, now power of a product, like I kind of showed in here, we have a couple things inside. So let's say we have x times y to the nth power. All this is saying is everything inside gets raised to the power on the outside. So let's take a look here. So let's say I have negative 3, x to the 4th, y to the 6th, and I want to raise this to the 4th. So I'm going to take negative 3, raise it to the 4th. Notice how I kept that in parentheses. X to the 4th, raise that to the 4th. And then y to the 6th, raise that to the 4th. So negative 3 to the 4th becomes negative 3 times negative 3 times negative 3. I have 4 factors of negative 3. And an easy way to do this is to take the first two. That's going to give me a positive 9. Then next you're going to give me a positive 9. So that's going to give me an 81, a positive 81. And again, I'm going back up to the previous law. I have a power to a power. So I multiply the exponents. 4 times 4 will give me 16. Likewise over here, I'm going to get 81 x to the 16th, y to the 24th. Let's take a look at a negative 2, m squared, n to the 5th. Now let's cube this. So now we're going to get negative 2 cubed, m squared cubed, n to the 5th cubed. Now you don't have to write it out this way. I just think it's easier, especially as we're going back over this, if it's been a while, just to make it a little bit easier here. Now, when we have a negative 2 cubed, we have an odd amount of negatives here. So this will actually give us a positive 4 times a negative 2, which will give us a negative 8. So when we're raising a negative base to a odd power, it's going to stay negative. So we're going to get a negative 8. Again, multiply the exponents, m to the 6th, and then n to the 15th. Now, a slightly different approach to this is if I had, say, 4 to the x times 5 to the x. Here we're actually starting out with this side of the law. So I have 2 different bases raised to the same exponent. So what this means is I could rewrite this saying that I have this x exponent on the outside here. Because wouldn't you agree, if I have this here, it becomes 4 to the x times 5 to the x. But now because they're both numbers, I could say that this is, and I really don't need the parentheses, this is just 20 to the x. All right, so let's take a look at negative exponents. Let's say we had x to the negative 4th. I don't know if you guys remember that this becomes 1 over x to the 4th. So negative exponents means just to flip the power or to take the reciprocal. So let's practice some of these. And it really comes from this type of a problem. If I were to just subtract the exponents and leave the x up top, I would have 2 minus 5, which becomes a negative 3. Or if I were to answer this question, where do we have more x's in our denominator? How many more? 3. And then I'd have a 1 up there. So x to the negative 3rd equals 1 over x cubed. So we could say x to the negative n becomes 1 over x to the positive n. So we take the reciprocal here. So let's say we'll call that example 1. Let's look at another example. Let's say we have 2 over m to the negative 5th. Now this 2 is just a coefficient and it is perfectly fine up top. So I'm going to leave it. But m to the negative 5th is not okay. So I need to flip it. I need to take its reciprocal. And that's all we could really do with that problem. Now we can have negative exponents up top, a combination of them. So let's say we have 5x to the negative 3rd, y to the negative 2nd over negative 10, x to the 7th, y to the negative 4th. So we just have to go through carefully and see what's going to stay, And what's going to move? Well, the 5 and the negative 10 are coefficients, so they don't follow this law. They're going to stay there. So I'm going to leave those there for right now. And I'm just going to go through and flip any negative power. So that's going to be x to the negative third. That's going to move to the bottom and become positive. X to the 7th is okay down there. And then both the y's need to flip. So I'm going to get a positive y to the 4th up top and a y squared in the denominator. So now I can go through and say, well, 5 goes into itself once, into negative 10 twice. So now I know I just have a negative 2 in my denominator. All of my x's are at the bottom, so I'm going to add up how many factors I have down there. It's going to be x to the 10th. And then for the y's, we're going to ask ourselves, where do we have more y's? Up top. How many more? 2. So we have completely simplified this problem. Like I said, there are so many different types of problems we could look at. Now there's a couple ways to look at this next problem, x to the 5th times x to the negative 4th. Again, I could picture this over a 1, and then we could just move the x to the negative 4th, flip that, so now this becomes x to the 5th is okay up here, x to 4th goes to the bottom. It just gives us a better way to see this. So where do we have more factors of x? Up top. How many more? Just 1. Or we could have just added the exponents, stayed our base once, and do 5 plus a negative 4, which will also give us x to the 1st. Let's try one more type with that property. Let's say we have a 3x to the negative 2nd over y to the 4th, and this is all raised to the negative 1st. So what we could do, I wouldn't recommend moving anything inside. I would go back to the power of a product property and just simply raise everything to the negative 1st. So we have 3 to the negative 1st, x to the negative 2nd to the negative 1st, y to the 4th to the negative 1st. So still, this becomes 3 to the negative 1st. This will now, by multiplying the exponents, will become x to the positive 2nd, and then I'm going to get y to the negative 4th. So two things have to move, 3 to the negative 1st and y to the negative 4th. So the x squared is okay up top, y to the 4th moves up to join it, and then 3 to the 1st will just stay at the bottom. So now I get x squared, y to the 4th, all over 3. All right, and we just have a few more different examples to look at. So I want you to pause the video to copy this down, but it pretty much says when adding and subtracting terms, only combine terms that are similar, terms that have the same variables and the same exponents. Only add or subtract the coefficients. So after doing these exponent problems for a little bit, when we see something like this, they look a little different. So for instance, number 1 here, I have y to the a plus 2y to the a. I'm not multiplying anything here. All I really am saying is these items I have 1y to the a plus 2y to the a, so then I have a total of 3y to the a's. Over here for number 2, I have a 3 to the x plus 3 to the x, so I really have 2 of these 3 to the x's. Now I can't simplify this any further, but if I could, let's say that this happened to be a 3. What if I had 3 times 3 to the x? Now they have the same base. So I'm just going to kind of leave you with that thought. That might be a homework question. All right, so again, we're just reviewing all the laws of exponents. Your assignment is to work on this factoring worksheet 3, 1 through 27. So I will have this as a separate PDF post. And we're still going to continue more tomorrow. At the very bottom, I have more practice with factoring. So as always, guys, take care. Let me know if you have any questions.